So, determine of brightness of meteors is a fairly standard operation for those captured by video camera. These procedures have their limitations, but the results are generally. But what about determining brightness in the case of photographic meteors? If you use the same methodology, will the result be comparable? I made several tests and comparisons on meteors recorded simultaneously by video cameras and digital still cameras. The result should be the subject of wider discussion on meteor photometry. So my motivation, when I started observing meteors, the only available and effective technique was naked eye. It was very many years ago, and I will not forget Thursday's 1982 when we saw outburst. Frequency up to 400 meters per hour, and of course Leonids in Almeria in Spain when we see 80 meters per minute and 13,000 meters per night. As we got older and technology began to improve, we also made our first attempts at photography. First on film, and later at the turn of the millennium, there were already the first attempts with PCD cameras. I was poking around the Matrox Meteor graphics card to try Circos Metrec, but then I discovered UFO suite and started trafficking meteors with video cameras. It was hectic, but I missed the nice pictures of the meteors. So in addition to camera work, I started photographing meteors again with digital cameras and small CCD cameras. Looking through and cleaning discs through COVID era, I found that I had thousands of CCD meteors and hundreds of nice color meteors with digital camera over the years. So I started thinking about what can be done with such data. Here is one example. Photometry. Comparison of meteor photometry captured by video camera and digital camera. So next. This is one nice meteor during outburst of Draconids in Italy, and it is image from Vatek camera and Edmax picture. So this we used meteor photometry process. You know about it. Photometry of reference stars in the field of view by PSF method. Construction with graph, which is a relation between brightness of stars and in the image and their magnitude of the reference stars. Calculation graph formula by least squares approximation. Then collecting pixels affected by meteors on each frame and summation of its brightnesses. And then calculation of meteor magnitude in each frame by using graph formula from step 1. And last step, construction the graph of meteor light curve from frame magnitudes calculated in step 2 and determination of meteor magnitude as peak brightness in the graph. And here is the result. It is luminosity versus frame, and this again is there was no data from in the video, or UFO analyzer don't accepted these frames for calculation. So we have 60 frames with meteor, and the gap is the frame is 1/50 of seconds, because camera Batek used interlaced image. So in one frame we have two images. So, and here is meteor magnitude calculated by this star, and you can see that maximum magnitude was around -4, so it is probably volatile. So it is big magnitude, and the velocity of this meteor, this important volume, and this is the sun picture, not a maximum picture of this meteor. You can see that there are much more stars and many more lights in meteor, and it is more real than this at max picture. This is the picture in digital camera. I use 16 years. I use the same Nikon D300, and one of the best lens, Tokina. It is wide angle lens, and it has very sharp images. And ISO 2050 and exposure 8 seconds. And I save these images as JPEG fine compression picture. So the used photometry process is near the same as in case of video, but for the stars, but for the meteor, the process is a little different, because I crop meteor image and some luminosity by each column, and construction the graph of meteor light curve from column summary, and binding data for comparison same time interval brightnesses, and then calculation magnitude by binning using graph formula from step 1, and determination of meteor magnitude at bigger brightness in that graph. So this is the luminosity channel of picture before meteor. It was used to extract only meteor from image. This is the 8 seconds later meteor image, also luminosity channel, and there is subtraction. We can see only the meteor. So from this picture is made astrometry and also photometrical data for stars. I made it by Astral software. It is very good software for astrometry, mostly used by observers, minor planet observers. And you can see that all the stars are a reference. And here is the position on the image. Here is the luminosity of the stars and the coordination, and it is catalog magnitudes of the stars. And important volume is full width of peak of the stars. You can see that this volume is quite good. If we remember that the exposure was 8 seconds, and for 8 seconds the picture was moved. And here you can see also signal to noise ratio. This is also very good image, very good values. You can see that here is the star 6 or 8, and it is signal to noise ratio 22 around. Very good. So if we have this table and this data, we can make a relationship between luminosity and magnitude and calculate 0 point. Once we calculate raw magnitudes from luminosity, as you know it, this equation, and if we have catalog magnitudes for any reference stars, we can calculate 0 point for that equation, which is the number that gets added to each raw magnitude to determine its catalog magnitude. The more stars, the merrier, but the 0 point only requires one reference star to work if we have no stars. For our image, result is 12.47. So meteor measurement, it is crucial. We can compare. We compare this one and this one. Yeah, it is image in true size of meteor taken by Vatek camera, and it is the true size of meteor taken by night one. So the difference is really big. So we will use following method. We rotate this image for this direction of light to be parallel on by the horizontal axis. Subsequently, cut the meteor, and that includes as little as possible to the background. So, like one, and gradually add up the pixel volumes in the column perpendicular by the to the direction of meteor flight, like this. Here is the summary of pixel brightness for each cone. Here is the cutting meteor image. You can see some noise after subtraction because there was JPEG images and there are artifacts on images, so the subtraction is not ideal. It's not total. Yeah.
Roman, can you conclude your own start time?
2 minutes.
One and a half.
Okay. So it is a summary of pixel brightness for each phone. It is nice curve. And determination of magnitude is a key part of our measurement. Since we compare the meteor from LaTeX and meteor from Nikon, and results gave us this volume, and after that the velocity of meteor was 4.66 near the volume of meteor from LaTeX. And so now we need to bin these columns to have some data for comparing, and then we calculate the magnitude of meteor. You can see that because explosion of from Nikon was 8 seconds and binding was 1/25 seconds, we need to magnify this volume by 200. So it is magnitude curve of the meteor from Nikon, and the maximum volume is minus 2.99. So this is comparison of brightness measurement from radio and digital photography. So conclusions is not so that bad. Good news. Photometry of digital meteors makes sense. Yeah? The accuracy of measurements and the reality of the result is at least at the level of video meteors and can be ordered with magnitude higher, maybe 2 magnitude higher. The potential lies in the color measurement. And bad news, without knowing the speed of meteor, we won't get this far. So if we have a meteor image without video image, video capture, we don't, we could not determine the velocity, and it is a problem. Next, there are no tools for this type of measurement. It's all manual work, which is also quite time consuming. And methodology must be developed to combine such data with the result of the other methods of meteor observation. And winter is coming.